Good evening, everyone, to this 2 hours masterclass on designing and building future-ready semiconductor system organized by Drive under the PSA, Principal Scientific Advisor to the Government of India. And we welcome you all for this masterclass. I'm Sumit Kanu and I represent Zenith Railway Academy. We are in collaboration with Drive developing programs on semiconductors and ESDMs. And I would welcome all of you once again, and let's start the session. So about Drive, Drive is a Delhi Research Implementation and Innovation, which is a science and technology cluster of Principal Scientific Advisor to the Government of India. It has been formed to create an ecosystem of industry, academia, and government bodies for taking innovations from lab to market. So one of the mandate for Drive is to do skill development. So going forward, Drive has collaborated with top of the academic institutions in India, including IITs, triple IITs, many universities of repute. Along with academic collaborations, Drive has also collaborated with many industry and corporations like Mahindra, Renew Power, Sony, Yamaha, BSES, BHEL, and many companies of repute. In addition to this, they are also in close coordination with various ministries, as you can see here on your screen, from Niti Aayog to DPCC to Ministry of Heavy Industries, in developing technologies, promoting technologies from lab to market. Now, coming to today's agenda, so this is going to be a 90-minute technical session conducted by various experts, which I'll be introducing in a short while. So we will first start with India's semiconductor mission and what are the global shifts we are seeing, which will impact. And Raju, we will be recording this and would be hosting this on our YouTube channel. So you can definitely get the recordings of the session. So in the opening context, we'll be starting with semiconductor missions and global shifts, followed by 4 sessions, which are technical in nature and would be done by our technical experts on heterogeneous integration and 3D packaging in AI, 5G, and automotive. Then signal and power integrity in high-speed systems, semiconductor reliability, yield modeling, and ESDs, and then system level modeling and hardware software co-simulations. Post that, I would like to also introduce few of the upcoming course programs which IIT Delhi and Drive are developing and would be launching very soon. So we will have a Q&A session followed by the session, individual sessions, followed by program overview, and then we'll conclude the session today. So going forward, the masters for today's session are Mr. Madhukar. I think just a moment. I think I'm opening a wrong.
Your name is missed. Yeah.
No, sir. I think I have I think this is the presentation, which I'm just a moment. I think I opened a wrong presentation. Just a second, sir. Let me just. Yeah, I think this has the. This again has the wrong presentation. Okay, I think, sir, I missed the, there is a mistake here. I'm really sorry about this. So we have Mr. Madhukar Tripathi who has joined us and from representing Anirudh. We have Mr. Akash Jain who's there. Varun ji, has Akash ji joined today's meeting? Can we? Let me see if Akash ji has joined. Akash BR, is it you? Akash?
Yes, sir.
Okay, thank you, Akash.
I'm not that, sir.
Okay. Akash ji would be joining us very soon. Then we have Mr. Vinod Kakde from Director Niti Aayog. And we have Mr. Varun Raj, who's the Chief Technical Officer from Technology Officer from Drive, IIT Delhi alumni. So so Vinod Kakde sir, Madhukar Tripathi sir, Akash Jain, and Varun ji would be taking various sessions today in this presentation. And now I'll move to the core agenda, why this particular masterclass. So we have been seeing a lot of initiatives by various training organizations, academia on ESDM and semiconductor. But as from Drive and IIT Delhi perspective, we started to think that the real opportunity for India would unfold when we will move beyond basics. So we wanted to explore horizons of advanced topics in ESDM and semiconductors, and that is the reason we started working on this masterclass and collaborations with industry and academia to launch new age or futuristic programs that will be relevant for the industry. So this is reason number one why we organized this masterclass. We wanted to present you the latest cutting edge technologies that will be shaping the semiconductor ecosystem in next few years. Secondly, we wanted to introduce you to IIT Delhi and Drive programs in ESDM and semiconductors for you to consider for upskilling and knowledge gain. And third one, we wanted to invite you to join community of learners who are interested to enhance their learning in the semiconductor space. So these are the two programs that we have presently worked with IIT Delhi. One is on analog and power management IC designs. We have already conducted one batch which saw participation from top semiconductor companies, including Apple from US. So there have been participants who have attended this program. And first cohort is complete now. We'll be planning a next cohort in the month of November. Additionally, we are coming up with an executive program in ESDM and semiconductor technologies, which we will talk later in the presentation today. For people who are interested to learn and get invitations to participate in master classes like this that we are organizing today, we request you to scan the QR code or find Learn ESDM on LinkedIn and subscribe to it. The recording of today's session will also be hosted on this LinkedIn page. Will be shared on this LinkedIn page. So you may subscribe to this, follow this particular page on LinkedIn to get updates on our training programs, master classes, free training nuggets that we'll be launching very soon, and even podcast with industry experts you will be able to get right on this LinkedIn page. So with this, I would like to invite Vinod Kakde sir to start his session on India's semiconductor mission and global shifts. Vinod sir, kindly you may share your screen and start the session. Okay, just a second, sir. Yeah, I'm unmuting you, sir.
Okay,
Okay,
1 second.
let me stop sharing. Yes, sir. In the meantime, participants, if you could just introduce yourself in the chat box and let me know what all you're looking forward from this masterclass. So if you could do that, this will give us a very good idea about the kind of questions we should be. I'll post Ganesh. I will post the LinkedIn page URL in a short while once Vinod Kakde sir starts the session. In the meantime, if you could just introduce yourself, what you are doing. If you're already working in the semiconductor industry, please let us know your profile. And if you have any particular question, do let us know. We'll be very happy to take that up towards the end of the session. Okay, so Balakumar is from ELK Education. Vinod sir, are you sharing the screen, please?
Yes, I am ready to share now.
Please share, sir. Yeah.
Are you able to see?
Not yet, sir. Okay, Parvati, you're doing research. Okay, Sudha, you see, damn. Okay, Logic Fruit Technology, Jai Krishna. Okay, nice to have you here. Dr. Mayur, okay, Pimpri Chinchwad University. Welcome, Dr. Mayur.
Once again,
Thank you, Madhukarji. I'm sorry for that name. I changed it, but somehow not able to see it now. Really, sincere apologies. Bhuvnesh, yes. Jerin, Don Bosco Group of Education. Okay. SMT in. Okay. Okay. Durgam. Okay. AMD. That's good. We looking forward to. And somebody is from Railways also. Okay. Geetesh Gupta. Okay. Analog Layout Engineer. Okay. Very nice. Arvind, this person. Sir, are you, is there some issue you're facing, Vinod, sir?
Yes, I'm facing a challenge. I'm not able to share it. I don't know.
Okay, okay. Let me just let me make you a host. Let me see if you're able to do that. Let me see. Let me just uh, I'm making you host, sir. Please see if you're able to
Okay.
are you able to do this right now?
You are the host now. Okay. Share. Is it coming now?
Not yet, sir. Not yet, sir. Or should I start? Should I run the PPT?
That would be better. You can start. I will start giving my comments.
Okay, sir. Okay. You may please go ahead, sir. Right.
Yes. Yeah.
Okay, so before you start, sir, let me just share. So we'll be taking the Q&As after the session is complete. If you have queries, please type in the chat. We'll take them up at appropriate intervals. There will be a bio break at 8:30 p.m. for 5 minutes. And I would request you to switch on your cameras at the end of the session for conclusion. So, sir, please go ahead. Is everybody able to see the
Yes.
screen? Please, okay, please go ahead, sir. Let me know when you want the slide transitions to happen. I'll do that.
Sure. Thank you, Sumit. Good evening, everyone. And thank you for giving me this opportunity to represent my organization and present before August audience about the Indian Semiconductor Mission and what the scheme plans to do for the future. So I start with the Indian Semiconductor Mission. This is a strategic initiative which was launched by Government of India in December 2021 under the Ministry of MIT and promoted by Niti Aayog to establish India on a global hub for semiconductor display manufacturing and design. Basically, it aims at reducing the dependence on imported semiconductor, which accounts for about say 65 to 70% of total India's electronic component import. Next slide. Next. Yes. So we'll look at what is the global semiconductor landscape, and then we will look into how India is progressing on that front. So typically, the global market size, as measured in 2020, is approximately 600 billion, which is now 697 billion in 2025, and which is projected to reach $1 trillion by 2030. The majorly the growth is driven by upcoming technologies such as AI, 5G, automotive, IoT, quantum computing, advanced computing, edge computing. So these are the leading technologies which are driving the growth of semiconductor industry globally. And also there are a lot of efforts put up by global bodies such as US Chips Act, which has contributed close to $52 billion EU Chips Act, Euro 43 billion, Japan, Korea investments, and also India is also investing heavily in this. And you would be glad to know that hello, can you see it now? Yeah. So
Yes, sir, we can see. Please continue.
yes. So Indian government has increased the budget for ISM 2.0. It will be close to 1.25 lakh crores now from 76,000 crores. So it's we are going in the right direction, and it is also needed for supply chain resilience and geographic diversification. That is the global landscape of semiconductor industry. Next slide, please. So Futurum Research has published this report from which we have taken this snapshot as to how semiconductor companies globally are grabbing the market share. This is 2024. The market has risen to close to $697 billion. And you can see all the top-notch companies. They have acquired almost 7% of the total market, with NVIDIA topping the list, close to 16% of market share. You have all the big players such as Samsung, Intel, MediaTek, AMC, Micron, Qualcomm, all the top-notch companies, top 10 companies, they represent almost 70% of the market share. Next slide. Yes. So this is again one graph we had taken from one of the published media reports, in which the companies they represent. These are top. One second. Yeah, if you break down the data, revenue versus the year for the top 20 companies with equal proportion per segment. So we have divided it into the 5 major segments such as equipment manufacturing, fabless, IP, for manufacturing, IDM, packaging, assembly. So if you look at year-wise, the breakdown is given and how much revenue the top companies are earning, you can see. Also, the similar breakdown in terms of year, what is the net income of the top companies with respect to the segments is also broken. That is the year-wise. Both the years are compared, and you can see that how companies are performing. And in the graph too, you will see that fabless IP is where the company is focusing a lot. Their focus is on the outsourcing. Design market and semiconductor chips, and they are also outsourcing. Next slide. Yes, again, this is a McKinsey report. And McKinsey has tabulated what are the key technologies which are shaping the semiconductor industry. You can see that they have broadly classified this into 3 buckets: the advanced packaging, advanced material, and AI-enabled manufacturing and design. So you can see that AI is basically driving the growth of future technologies, and also it is fueling the growth for semiconductor industry as well. And on the left hand side, you will see the overall growth in global semiconductor market, which is driven by the technologies like automotive, data storage, and wireless industries. And it is projected that compared to 2021, in 2030, you will have almost 7% CAGR with all the segments growing. And the maximum growth will be seen in computing and data storage, followed by wireless communication, automotive electronics, industrial electronics, consumer electronics, wired communication. These all segments will fuel the growth for semiconductor industry in coming years. And the growth contribution per vertical, you can see, is in the range of approximately 30%. Next slide. Yes, this is again a snapshot by McKinsey and Co. In which you can see that how AI and machine learning skills have they have been replacing the system architecture knowledge on the European job market, and also the worldwide how they are performing. So if you see the segments such as memory, fabless semiconductor, microprocessing unit, capital equipment, foundry, you will see that top-notch companies take place in the top league. So in the memory, you will see Micron, Samsung, SK Hynix, Western Digital acquiring almost 95% market share. Similarly, in the fabless semiconductor, you will see Apple, Broadcom, Nvidia, Qualcomm, followed by Intel, and all the leading companies you will see they are performing heavily. And if you look at the right-hand side graph, you will see that what are the technologies which are shaping. So you have systems architecture, SoC, SOP, complex ASIC design, data analysis. So this graph shows it compares the 2 year 2020 and 2022, and you will see that how the top skills are replacing. So you will see top 3 skills which were systems architecture, data analysis, and AI and machine learning. So you see that number 3 is taking the first place now. AI and machine learning is superseding the other things which are required. Knowledge applications, outlay, reliability, hardware, software, security, knowledge at new material, analog design. So you will see that the top position which was acquired in 2020 are replaced by AI, machine learning, and knowledge is taking the precedence over the traditional skills. Next slide. Yes. So this is the where we stand. About 70% of growth is predicted to be driven by just 3 industries: automotive, computation, data storage, and wireless. So you can see that as per the Society of Automotive Engineers, level 4 car with an electric drive train could be about $4,000 as compared to 500 for an SEI level 1 car powered by the IC engine. So you see there is a change of shift here now. The traditional IC engine being replaced by electric drive. So everything is now electric driven actually. So you see that even in the automotive sector, semiconductor industry is fueling the growth for new electric vehicle now. Next slide. So this is the forecast for the talent which is required by 2030. This is a European snapshot. You see in 2021, almost 200K were the number of professionals working in the semiconductor industry in Europe. And the projection is by 2030, this will be 3 times of what the working professional is. So you have a talent gap of almost 350K. And it is estimated that talent by 2030, 120K would be supplied. And so there will still be a gap of 350K, 350,000 professionals in European Union. So that is, so you can see that huge employment generation will be fueled by semiconductor growth. Next slide. So let's talk of the Indian, what India is doing in semiconductor industry, how the growth is fueling. So as I have already told, India's semiconductor mission in 2021 with an outlay of 76,000 crore incentive. And of these incentive, close to, this was broken into three parts actually. I will tell you the breakup, how the breakup was there. So with a budgetary support of 76,000 crore, 65,000 crore was for chip manufacturing and packaging unit. 10,000 crore was outlaid for modernizing the semiconductor lab at Mohali, and 1,000 crore was for design linked incentive scheme. Okay, so what was the aim actually? The aim was to establish fabrication units, packaging units, and design ecosystem, and to build a vibrant ecosystem around the semiconductor industry, reduce import dependency, promotion and innovation with related technologies, increase the global competitiveness of India, job creation in this field, and skill development. So the global competitiveness, this will position India as a key player in the global semiconductor market, which is supposed to reach, it is projected to reach $1 trillion by 2030, and India aims to achieve at least 10% of the total market share. Also on the skill development front, India needs to develop a skilled workforce targeting close to 85,000 engineers and technicians across 113 academic institutions. Next slide. Yes, so look at what are the major investments and projects in India which are attracted by ISM, Indian Semiconductor Mission. The mission has attracted investments worth over $1.5 trillion. That is a major achievement. And the key investments have been 2.75 billion ATMP plant at Sanand, Gujarat. Tata Electronics has invested close to $11 billion, which is for a proposed fabrication plant in Dholera, Gujarat. ISMC Analog has put up a proposal of $3 billion in Karnataka. CG Power and others under DLI scheme for design innovation. HCL and Foxconn, they have joint ventured for a 3,700 crore facility in Jewar to produce display driver chips with a capacity of 36 million units monthly. So these are some of the snapshots of the ISM scheme which is being launched. Next slide. Yes. So now in the ministry, the discussion is going on the second phase of ISM. The second phase of India Semiconductor Mission is expected to have a fresh budgetary allocation of 15 billion. From 10 billion, we are going up to $15 billion, approximately 1.25 lakh crores. This follows the initial phase, which was 76,000 crore outlay. The second phase will focus on strengthening the semiconductor ecosystem, support for raw materials, equipments, and specialty chemicals which are used in the manufacturing. Also, the government of India plans to provide additional support for gases and other elements which are essential for semiconductor production. And on the similar lines, a $10 billion project by Tower Semiconductor in conjunction with Adani for a chip manufacturing unit in Maharashtra is also proposed under the second phase of ISM. Next slide. Next, please. Yes. So now you see on the skill development on the employment front, uh, India holds close to 20% of the global chip design workforce, according to ISA, and 50,000 plus engineers are working in the semiconductor design in India, which is estimated to reach 250,000 by 2030. And you see the emerging roles are process engineers, packaging specialist, reliability analyst. Also, there is huge requirement in the foundry and the semiconductor welders. It's a specialty skill, and you will see that a lot of job market will be created in those specialized areas by the growth of semiconductor industry. Next slide. Next, please. Yes. So let's see at the India's global positioning by 2030. Currently, our share is less than 1% in the global semiconductor manufacturing, and by 2030, we plan to close to 10% of the market share. This will be achieved by focusing on design, packaging, and specialty fabs. Also in the domestic market, which is supposed to reach, which has already reached $500 billion by the end of 2025, and this will be fueled by academic and R&D partnership. Already, you will see that ANRF, Anusandhan National Research Foundation, which is a flagship program under the Ministry of Science and Technology, is promoting research and development ecosystem, and in which semiconductor is also acquiring a huge space now. So in the coming years, you will see a lot of R&D institutes putting up research and fabrication around the semiconductor industry. Next slide. Key takeaways from my presentation: India is investing heavily to become a semiconductor powerhouse. This will be achieved by global realignments favoring India's talent and design base, which will create massive demand projected for the skilled semiconductor professionals. And our program, which is a 100-hour program, also aligns with this transformation. Next slide. So let's see what is the global shift which is creating opportunity for India. Geopolitical shifts drive decentralization away from East. The focus which was on the China, Taiwan, and South Korea is now slowly shifting towards India. And India is definitely benefiting from China plus one strategy, where every country is looking for an alternative to China, and in which India sees a prospective global opportunity in becoming a semiconductor hub in coming years. 70% of the global semiconductor firms have India R&D presence, which are very heartening news. This comprises of outsourcing of design, testing, system modeling. These are the in the growth phase in India. And as I've already told that the job market would be close to 250,000 plus skilled engineers and analyst job by 2030. Next slide. So yes, so you'll see rising roles not only in the design and verification. You will have a lot of opportunities in ATMP and reliability testing, DFT, ESL modeling, signal integrity, system integration, power packaging. So you will see a big ecosystem developed across semiconductor industry, and new type of jobs and new skills would be required for meeting the needs of semiconductor industry. And you will see that a lot of collaboration between the industry and academia to fill the skill gaps, such as ANRF, Science and Technology Department, ISM, and also Niti Aayog on the policy front is pushing for new initiatives and new collaboration with industry, academia, and the corporates. Right. Next slide. Next slide. Yes. So, what is the future outlook which is holding for the semiconductor industry? The ISM is poised to transfer India's semiconductor landscape through increased budget allocation. It is proposed India Semiconductor Research Center, which will focus on niche technologies such as quantum computing and 5G wireless technologies. Government's proactive policies combined with private investment from companies such as Tata, Micron, and Foxconn, and international collaboration will position India to achieve significant milestones, such as rolling out its first chip by September 2025. So you will see that India will roll out its first 3 months, and we will have our first fab to be operationalized by 2026. And India is set to generate an impressive 800K to almost 1 million jobs in semiconductor industry over the next 5 years. So this is very promising future outlook, which is presented by ISM in coming years. Next slide. Next.
You come to a conclusion, sir. Thank you, Vinod, sir,
Yes.
for
Yeah, so
your session. Hello.
Yes, please.
Yes.
Yeah,
Yes.
please go ahead.
Yes. Thank you, Vinod, sir, for this quick take on opportunity shaping up India's semiconductor growth story. I have a question for you, sir, before we conclude your session. Sir, is there a plan for plan for test houses or setups for industry under ISM?
Yes, this will be covered in ISM phase 2, which is under consideration. So we have definitely plans for that. And Niti Aayog is making policies for that. So definitely it will be there.
Okay. Thank you so much, Vinod, sir, for your insights. And I would now like to welcome our second expert, Mr. Madhukar Tripathi from Anritsu, India. The intent of having Madhukar sir on this in this masterclass has been to bring in the industry perspective. So you've heard the perspective of Vinod Kakde sir, who represents the government, the policy making side of for semiconductors. Now we will hear and see what industry is thinking about semiconductors around, and especially about talent development. So I invite Madhukar sir to please share his presentation. I'm stopping the presentation, sir, and I'm also unmuting. Yes, I've requested for you to unmute, sir.
Hello, Sumit, can you hear me?
Yes, sir. Yes, I can. I can.
Very good. So, good evening, everyone, and thank you so much, Sumit for introduction, and Varun for giving the opportunity to be here in this part of a very good emerging program, which is very useful for entire industry. And a lot of thanks to Vinod sir specifically because I mean he set the tone very right, and I have already all those points here in my presentation also. You will see some common things there, but yeah, definitely that shows this. I mean, entire industry is looking at the same things for a better ecosystem from regulatory or government point of view. Vinodji presented, and I will be taking up the things from industry perspective. So let's start. Yeah. Thank you again. And I'm working with Anritsu for last 18 years. And now at the moment, I'm responsible for marketing and business development for test equipments to the various industries. And content for today's presentation is like a brief introduction to the company, which will give you the insight what we do, who are we, and now how the India is, progressing towards the semiconductor things or electronics in general, and what are the drivers for growth of industry, electronics industry in particular, and how a process take place for electronic system design, and what are the challenges when we design a electronic system, and what should be, key points to consider when you want to select a, good test equipments for manufacturing process in the electronic section. And then of course that should be covered from right from R&D to the mass production, because ultimately that is the goal when you are able to deliver the goods to the industry. And then within that, like we will cover latest topic like Vinodji mentioned, AI, data center, how it is, tested, and then a lot of wireless devices are, around us. We will also look at how they are tested, what are the testing for them, and then of course, like Vinodji mentioned, 5G is also, already here in India, and that is opening a growth path for overall electronics industry. So we will cover a 5G base station testing also. And then the other part of testing, which is like radar or digital to analog conversion, analog to digital conversion testing, because these are the cards which are, very much required when you are developing a new system for high speed internet access or any other design. And likewise, at the back end, other than wireless, there is a good role of the optical technology also. So we'll just touch those two, three points of optical module also. And then finally, the signal integrity, just one slide, an introduction and importance of it. And with this will give you a confidence that like who are we and with whom we are already working, and how we can contribute to a similar ecosystem for a good, growth in the electronic sector. Yeah. We are basically now in 130th year of our establishment, and RISU is celebrating 130th year of establishment. We are a Japanese company with a headquarter in Japan, and now we have three factories worldwide. There's nothing beyond US and Japan. So most of the products are manufactured in Japan, which is left hand side on the screen. This is our factory view. We have two factories in Japan and one is in US. So a lot of handheld and some benchtop equipments come from US. And here we will see the history, like we started early in 1895, and we have given a lot of words first, test equipment to the wireless industry, to the communication industry. For example, when there was no wireless communication as such, or it was just I mean, payphone, coin phone actually. So we were producing that at the same time in like 1953, and in 1954 we manufactured the first kind of microwave measurement test equipment, and then the on the wired network side we were first who produced the optical time domain reflectometer in 1981. Like fiber revolution was happening, so we called it OTDR nowadays. And likewise, there is a good history of, some first from Anderson side to the telecommunication industry, electronics industry. We are a part of, part of Andresu India team. We have three offices here. One is in Noida. I am from Noida office. Other is in Hyderabad for customer supports like Qualcomm and other in South. And then our Indian head office is Bangalore, which is also having a R&D facility here. And within India, we are celebrating this year 20th year of our direct presence. We have been there before through our partners, and our R&D is supporting a global customers from India. So I mean, we as an Indian part, we are contributing the global growth of system, electronic system and telecommunication industry. And In summary, we work with a lot of industries and technologies. To be more precise, we have test equipments for 5G. We have the test equipments for data center also, and then wireless connectivity, which is purely like a Bluetooth, short wireless, Wi-Fi, cellular. And then the 6G is emerging. We are 6G R&D people who are supporting a lot of academics in their testing of antennas and other equipments for 6G and material research for 6G. And we are also part of millimeter wave test solution provider, because that's the candidate for 5G and 6G going forward. And then we have a lot of high speed testing equipments also. And optical photonics network is also growing, because only it can handle a good amount of high speed data traffic. We have the test equipment for that. And of course, like Sir Vinod sir mentioned, automotive industry is growing and a lot of electronics going inside, and they are also one of the consumer of electronics components. We have test equipments for automotive electronics industry also. And then quantum is taking a shape already in India, and a lot of industries and academics institution like IIT Delhi and others, they have already demonstrated a communication system using quantum technology. We have a test solution for that. And Internet of Things, IoT, uh, RedCap is the other technology defined by 3GPP. We have a test solution for that. Other than that, the generic satellite communication or non-terrestrial network, NTN, we have a solution for it. When it comes to defense, we have a solution like for testing radar, TRX module, that can be a civil radar, that can be a military radar, likewise. So hopefully I mean, the speed is okay actually, Varunji or Sumit, or should I go slow a bit?
It's fine, sir. It's fine. Please go ahead.
Okay, great, great. Thank you. So electronics has entered in, every aspect of our life. If we can see whether it is a cellular phone or a navigation module or camera or our laptop, or even like this Google, if you see, it is actually launched by say Beta. It's called Meta Glass, and it is having a lot of features connected by Bluetooth speaker. You don't need actually a cell phone at all. It will be, if you have internet connection around, it will be connected, and then you can do a lot of things and your hands are free. And this is like latest super thing. I saw a demo just day before yesterday in Delhi of this product. And even electronics has entered in our kitchen. So like microwave oven or induction, they have a controller for electronics, things, and remotes are there, which is also a part of electronics only. Smart watches, smart home, radar, satellite, connected cars or ADAS or infotainment system. Latest inside the car, you can operate the whole car with your mobile phone because of the connectivity only. And then smart grid, because that is how we are getting power and controlling the entire power supply eco chain system with the help of electronics at the backside. And then of course our aviation industry is using a lot of electronics, right from communication to controlling the landing of the aeroplanes at the runway, ILS and all that. And then POS, like we go for a shopping, so point of sale, that is a wireless, now we can see. And then of course Wi-Fi to access the internet. This is how every step of life or everywhere we are seeing a role of electronics inside. Vinodji already covered this, so I'll just take two, three news which is just 2 days old or 3 days old. For example, as per Times of India, electronics industry and supply chain is on the path of growth, and we are expecting say roughly 500 billion industry, electronic industry production by 2030. And again, the one of the companies is investing $2 billion in R&D of semiconductor in Bangalore. Uh, then, uh, I mean, according to like PwC, one of the reports, India will be one of the good candidate as a destination for producing the electronics component and system. And latest, like Vinodji mentioned, Tata has already started a program of production of chips. So they have sent, hundreds of employees to Taiwan for training on that. So skilling is very important, and because of that, they are so that once they complete the training, they are able to produce the good quality products here in India. This is very latest news. You can see the dates in the slide. It is just like within 10 days, last 10 days. That shows the focus is here from government side, whether it is a chip production or data center or even our emerging technology, which is AI, artificial intelligence. It will also need a lot of electronics inside our components, electronics component. And like sir mentioned, yes, post-COVID, the world has realized that there is a need of, more than one supply chain ecosystem. Beyond China, they have to look. So India has emerged as a good candidate because of its unique advantage, low labor cost and space and other things. And then 5G has taken a shape already, which is contributing to the growth of telecommunication sector. Of course, electronics is now more inside after the EVs, the electrical vehicles are successful. We can see already on the road. And this is also, giving a demand of semiconductor electronics component. And the government has already taken a lot of steps, sir covered, but I'll just make one or two here for reference. Make in India, Digital India, these are the programs which are also, creating an ecosystem for having a good electronics supply chain inside India. And then the government is giving a lot of, money incentives so that industries are properly, focusing and able to deliver to the country and export the goods outside India. And apart from that, like sir mentioned, the collaboration from industry and academics is already a very good, in place, and government is funding more than 3,000 PhD students, for the research of electronics component systems at the different Indian institutions. And then finally, India Semiconductor Mission is well covered by Vinodji, and we'll go to the next step. Now, when we want to design any electronic system, there are basically three components. The first one is hardware design, and this is before like you do some simulation, and then you design the hardware part in the software, and then you design the software part also of that, which will control the hardware, and then a firmware which will be lying over the both together. So this is a very, I mean, there can be multiple steps or components, but I have tried to, give a main three components for any electronic hardware design part or system design. And then it happens with the concept of what you want to do, what you want to develop, and then you design in the software, and then you make a prototype. Now, finally, it is tested, and when it is, able to deliver whatever it has been designed for, then it goes to the next level of production likewise. So this is how a cycle of system design take place. And then it is not that simple, like shown in the previous slide. There are different challenges. So one is first is complexity, because I mean, now people are looking for a very small miniature components and a very high quality of the electronics item or customer experience, consumer experience. Everything inside, for example, an aeroplane have a 51 antenna, or your mobile phone has more than 5, 6 antenna, one for Bluetooth, one for navigation, GPS, one for Wi-Fi, other for cellular communication, likewise. So multiple complexities are involved or in the system designing. And then the other component is once you design and produce the equipment, it should be, well in the time to the market, because if you are not able to deliver your equipment, instruments or consumer goods in the time to the market, there is no point of, developing or producing them. Overall, it should be very cost effective so that people get the advantages at the of using it. If it is expensive, probably the success rate will be slower, and then it should be very reliable, because once people invest for any equipment, any instrument or any electronics good or system, they feel that it should be very reliable and stable. So these are the challenges which need to be, address when you are designing any electronic system. And once the design and prototype is taken place, then you have to test it for different functionalities which has been designed here. So it should be technically feasible is the first consideration we should look forward for when selecting an test and measurement equipment. That means like whatever it is designed, intended for that, is it meeting the requirement or not? And it should be also very effective. The expensive equipments will not, able to deliver the cost-effective the consumer goods or electronic system. And it should be future scalable. For example, today, if you are developing a 5G smartphone or a smartwatch which is, supporting the LT call, tomorrow it should be on the 5G network, and maybe going forward after a few years, it may be at a 6G also network somewhere, or a dedicated mission critical communication network. So the equipment should be fully scalable to meet the requirement of future needs. And then finally, it should be very easy to use, very less, time to learn the how to operate it, how to uh, do the functions, and less skilling should be there. That will actually make the success of any test equipment selection. These are the key criteria for selection. Now, here we will give you an overview that from Andasu side, we are involved in the industry, electronics industry, from R&D to mass production of lot of equipments. For example, left-hand side, you can see the smartphone is there. So tablet or cellular module, which are installed inside car or any other devices. On the right hand side, you can see the test equipment which are primarily required for any individual testing. If it is a research equipment, it should be very highly accurate and have a lot of functional and reliable test reports. When it comes to the production, it should be a multi-port devices, because time is very important or critical in production. You have to produce devices around the clock, like 24/7 factories are operating. So it should be able to test more and more devices. And at the production, you only need go no go kind of testing. While in the R&D phase, you need a very detailed R&D or test equipment to test each and every parameter defined by the standard bodies. It may be 3GPP, it may be PCI SIG, or it may be Bluetooth, or it may be USB LANs, or likewise. And the first and foremost component in an electronic system is actually IC, integrated circuit. We know, all of us, this is very important. So here it is a system or a process which is showing that how it is designed and tested. So pre-silicon verification is done, and then it is on kind of software only. And ASIC means like application specific integrated circuit. And then it goes to the post silicon test, where you need a test equipment, a number of test equipment. It may be a bit array tester or signal quality analyzer, and real-time oscilloscope or vector network analyzer for validation. When the IC tape out is clear, it should go to the mass production. And in mass production, like earlier I mentioned, there will be equipment which have a multiple port for testing. And then finally, there may be a system level test. For example, that IC is now fitted into a system, it should be again tested. So these are the different stages where we see any kind of high-speed digital system or any electronic system is tested, and what kind of test equipments are involved at various stages. And the product which we mentioned in the previous slide is targeting the like AI data center or edge AI, artificial intelligence, edge computing. Vinod sir mentioned already, these are the trending, emerging technology. High speed devices or internet access is now required at every place. So this equipment give you the data rate testing of 400G, 800G, which is very, very really high data rate. And any kind of the USB device, for example, in from phone or from PC, we want to transfer any data to any other storage devices which have a USB port. So it should happen in very less time. And that is how the testing happens when the any USB is being designed. Likewise, jitter tolerance is also tested in the any USB device or any other receiver device. Nowadays, we are also having a PCI, peripheral computer interface Gen 6, which is already in the place, and devices are being tested by different players like Cadence, Frambus, those kind of guys who are producing the high-speed buses. And all this equipment, when our IC is being produced, different quality of material is also being tested. And there are a few equipments which are primarily intended for testing the material quality only. So one of them is, we called it network analyzer, vector network analyzer, VNA, because we are already talking about millimeter wave and terahertz in the academics for research of 6G or FR3 frequency range. So we need a very broadband VNA which should be able to test the material from, say, very basic frequency to the higher frequency. So we have a VNA which works up to 220 gigahertz without any expander. Or if you want to test anything which is beyond 220 gigahertz, like in the range of sub terahertz, so we will provide an extender module which will give you the extended frequency operation of material testing. And likewise, on the optical side, there are active cables or direct and active electrical cables or copper cables or DAC direct attach cable. They are used in data center server racks to connect each other, and they are tested with this VNA on the right hand side, top one. And at the bottom, there are test equipment which is called part of optical VNA, we call it, because as I said, optical devices will be playing a role for high speed internet access. At the back end, the optical devices like O to E converter, optical to electrical, or electrical to optical converter, they should be also tested to handle the higher data transfer rate. And this is the equipment VNA is used for that purpose. And below you can see a very basic diagram, and on the left hand side as a concept side, on the right hand side you will see the actual real diagram of VNA you testing one material for high frequency with our VNA. And like artificial intelligence, AI is increasing. So semiconductor materials has been tested already, but after the fabrication of the device or final device, we have different testing equipment for different stages, as mentioned earlier in the slide. Vector network analyzer, VNA, and signal quality analyzer, they will be used for different data rates depending on technology. And on the right hand side, if you see the bird wave MP2110A, which is a like multi-channel equipment for testing the optical and electrical high-speed devices. So this is primarily used in the production testing. And for data center also similar equipments are used, but one new equipment is introduced at the bottom line. We have covered already the top line, but bottom line is like optical spectrum analyzer. So when you have the optical devices or modules, for example, SFPs or data cables, high-speed data cables, the spectral study happens with the optical spectrum analyzer. When the network is deployed, you have to test the throughput, latency, all those parameters in the network side. So right hand side, we have the handheld field testing equipment, which is used by data center commissioning people or the people who integrate the data center or hyper connected world, where one data center is connected to the other data center on a higher speed. So different tests are being conducted with this handheld equipment that is good for field and also for the lab, because this is battery operated and power, and the AC means power operated. And now we will be covering the wireless devices production. In particular, wireless device may be our smartphone or tablet, which is supporting the cellular technologies like 2G, 3G, 4G, or 6G, or new sub 6 gigahertz 5G bands. And it may be having a Bluetooth or wireless LAN connectivity. On the navigation side, as I said earlier, it may be having the GPS or GNSS rated cellular and plus navigation box tools inside, ICs inside. On the right hand side, like access point Wi-Fi router, we already have at our home. for broadband. It will be also having the different IEEE, supporting specification, Wi-Fi specification. And then at the same time nowadays, fixed FWA, fixed wireless access from 5G. So it will be having both cellular plus short wireless. And then IoT modules are there for, say, asset tracking. They are also using the connectivity modules on the lower frequency like Zigbee and GPS for navigation, but on the connectivity side, they are using say 2G, 3G, 4G, and even 5G sub 6 gigahertz. And the narrowband IoT devices, they also use these modules. And the latest traction is towards the automotive electronics that is used in the telematics, which is a connectivity module for navigation related things, GPS module. And for safety, V2X, like the radars are there, so they will actually detect how close is the object and apply the brake in the case of autonomous cars. So all these are, having some kind of connectivity as a wireless device that will be tested with the equipment shown in the middle. We called it MT8870A. It's a universal wireless test set because I mean, all kind of wireless testing, whether it is a short wireless or cellular wireless, it will be tested. And you can see multiple ports are there here in this box. So it is truly good for a production testing. That's what I mentioned earlier. And similarly, if you are making, for example, Samsung is our customer, Foxconn, who is making Apple phone in India, they are our customers. They are using these two boxes in production testing or final QA testing of the smartphones, being like we are using in India. And it supports all the things you can see in the center, whether it is a cellular technology like 5G and R, or the Wi-Fi different standards, even backend LTE advanced, and even 3G also WCDMA. And then on the navigation side, GLONASS, GPS, Galileo, all those things. On the entertainment side, FM testing is also possible. On the Bluetooth testing on the same box. That means you don't need a multiple box for just a production testing. A small form factor, multiple port, make it ideal for any production testing of any wireless device. We have a very good install base in India for this equipment from production side. Likewise, you can see the traditional method for testing a Wi-Fi router where there are multiple antennas. They are combined with the different divider and splitter. But if we have a multiple port device, each antenna can be connected to the individual ports, whether it is a 2.4 ISM antenna or it is a cellular antenna on 5 gigahertz or 6 gigahertz, even Wi-Fi antenna, and sub 6 gigahertz from the cellular 5G antenna, which is will be a two-in-one kind of router which will support the cellular plus Wi-Fi related connection. So this box is an ideal solution in production testing because of its capability of supporting multiple standards and the multiple ports. And we have the one other equipment which is on the component testing side. For example, we called it Shockline VNA, that is used for testing of the antenna. As mentioned, the aeroplane or any mobile device or any other device, it will for sure have at least one antenna, minimum antenna. It may be a dedicated antenna or a multi-band antenna for different purposes. So that antenna is tested with the VNA, and antenna bandwidth, impedance measurement, cable fault location, where is the fault if there is a connector and antenna connected by a cable, then what is the cable phase, cable return loss, all those are tested with this equipment. We called it Shockline VNA. This is available in different formats. You can see on the picture. Right hand side, it is one port, very small, easy to use. Multiple can be connected together. In fact, one of the iPhone vendor in Taiwan who makes the antenna for iPhone and other OEMs also, and they use this multiple equipments for testing in production and this kind of equipment. Then we have two port combination, we have four port combination also for different type of devices. The reason for using this equipment in R&D and production is it is very easy to use. You can see it's not like a complex, and then it is also giving a cost value proposition very small form factor. Depending on the size and space available, you can use either of the model. And yes, of course, this gives a very good cost-effective solution for production and R&D testing. We have supplied a lot of these VNAs to academics in India and outside India, also for research work in antenna lab or microwave lab inside India and outside. And like different connector manufacturers, they also use these VNAs for testing in R&D and production. And now we are covering the very important aspect of 5G. This equipment on the left hand side is a base station simulator, network simulator actually, and it is used for testing the base station. So again, for production, you need a multiple port. You can see here there are 4 ports and 4 base station modules can be tested at one go. So what happens once the base station 1 is being set up
Madhukar
and
sir,
initialized
Madhukar
and
sir,
tested?
can we take a 3 to 5 minutes break, sir? Just to.
Yeah, as you wish. Yeah, no problem.
I'll take up some questions, sir. Habib Khatun is asking, sir, if you could give some details about 3D IC packaging. Do we have that in your presentation, sir?
Not at maybe a post presentation.
Varunji, would you
We
take
can
it?
connect and then
Sure. So I
yeah,
think, sir, it's 8:47. Let's connect at 8:50. Let's take a 3-minute bio break right now.
all right. Okay. Yeah.
Sure. Right. Welcome back, participants. I can see some questions in the chat box, and let me see if I could. Yes. So, Varunji, I'm unmuting you. Yes, so I can see some questions. So participants, these equipments and products shown by Anritsu has an objective of why we are sharing, why Mr. Madhukar Tripathi is sharing these products with you is something that Varunji would be highlighting. There is a very strong reason behind this because I'll unmute Varunji and Madhukarji to.
Yes, yes. So, Madhukar ji, if you can just carry forward this presentation quickly, so then I'll take over. Madhukar ji,
Hello?
are you online?
Yeah, I'm here. Can you
Yeah.
hear me?
Yes, yes, yes. We can hear you,
Okay.
Madhukar ji. It was such a nice presentation. I was just engrossed in it. So, so the importance of this of showcasing these products is that these products are the core of electronic system, not only design but also testing and manufacturing. So right now, what in India we are trying to develop is the manufacturing ecosystem for the electronic systems and semiconductor industries. We already have got a lot of engineering talent which are stuck up in the back-end design activity. So, but what essentially Government of India wishes to do is to develop the ecosystem for manufacturing. So when this presentation was being showcased, the whole idea was to let the participants understand that how complex it is to manufacture and do the testing. Anritsu is one such company which provides such high level instruments to companies like Foxconn, Samsung, and AMD, which are into essentially, and Samsung also, which are essentially into the manufacturing activity of electronic system designs. So, Madhukar ji, if you can just conclude in some of your slides of
Yeah.
what we have in the store.
Oh, great.
Yes.
Yeah, thank you, Varunji, for making it very short. Yeah, overall, yes, we have the test equipments which are primarily focused for electronics industry, telecommunication industry,
Mm.
and we are very much familiar and known in the market. Like you can see the screen, all the global giants like Intel, Qualcomm, MediaTek, and XP, or even Indian operators like Jio, Airtel, or manufacturers like Sterlite Technology, HFCL, all these people, they are using our test equipment at different stages, testing the electronics and communication. On the government side, AI, or private side, Indigo, Bharat Electronics, Bell, ISRO, Indian Army, Navy, all those people, they are using our equipments for testing their test setup. And it plays a very important role actually in the overall success and customer experience. A good testing equipment only provides that experience and ensure that the product quality is very good. With this, I'll conclude my presentation. My contact is here. If we want to get it connected, my email ID, phone number, people can reach me. We can address. We work very closely with academics and industry for this. Once again, thank you, Varunji and Sumitji. Yes.
So, thank
Thank you,
you.
Madhukarji. Thank you so much for your. Uh,
So I can just start off my presentation, Sumit ji.
yes.
So I think
Could you change the view of this presentation?
yes, just a second. I'll let you.
Can we put it in the view mode, please?
Yes. Can we see the presentations,
Not
Sumit
yet,
ji?
not yet, not yet.
So can you share from from your
I'll
side?
do that. I'll do that. I'll
Yes,
do
please
that.
do it.
Let me
I
do
can't
this.
there is some requirement from.
Okay. So
Great, I can see.
so let me just
So to start with, let me give a brief idea of what the last two sessions were. I'm representing Drive. I'm the Chief Technology Officer of the Delhi Science and Technology Cluster under the August office of the Principal Scientific Advisor to the Government of India. And essentially, I'm a semiconductor and IC design engineer, essentially an analog IC designer, who has spent more than 15 years in industries, including Intel and ST Microelectronics, and in the later phase in the government defense labs before joining this science and technology cluster. So as we have already mentioned, one of our key mandates is to promote the government policies in the deep tech. And one of them is also about the semiconductors. Apart from semiconductors, we also deal with artificial intelligence, we deal with quantum computing and so forth. But right now we are focusing on semiconductors because semiconductor is a very growing market. And essentially, this is one of the markets which is the foundation of all the other fields. So the semiconductor industry is when I say semiconductor industry is the foundation, it means that the other industries, the high-tech industries, whether it be the electric vehicle industry, EV industry, AI, quantum computing, and other industries, they are all fueled by the ICs, which fall under this particular semiconductor industry. Ironically, India has been a very hot destination of IC designers. We have a great pool of more than 20 or 25,000 good designers, both in analog and digital field. But we are not doing so good when it comes to the manufacturing aspect of semiconductors as well as the electronics. So our import bills are rising rapidly, and with the present hostile international environment, we wish to be self-reliant in these critical technology areas. So Government of India has launched programs specifically for the manufacturing activity in semiconductors. It is called Semiconductor Mission, through which we plan to develop an entire ecosystem, which will not only make India a very self-reliant country in these critical technologies, but will also create jobs for our youths, and those jobs will be very meaningful and satisfying white-collar jobs, uh, uh, which will be which will not put India on the global map of technologies, but in fact we wish to lead this particular race. Let me start my presentation in a more formal way. So why this topic now? Obviously, as I said, that the growing demand of the semiconductor products. And when I say semiconductor products, it not only makes ICs, but semiconductor product also includes advanced materials. So we deal with high quality silicon, we deal with high quality gallium nitride, GaN, we deal with GASIC, gallium arsenide devices, indium phosphide devices. So these kind of materials also fall in the category of semiconductor field. So there is a misnomer that only electronic and electrical engineers are welcomed in this field. This is not so. We also require people from metallurgy background. We require people from chemical background. We require people from mechanical background, and obviously people from electrical, electronics, and computer sciences. We have role for every traditional engineering field because semiconductors is a very interdisciplinary area. And the courses which we plan to launch is all about manufacturing. It's not only will be limited to the design aspect. Obviously the design aspects will be taught, but such courses are running by multiple agencies, multiple IITs. So there is nothing much to add to what is already in the market. What we plan to do, and this is as per the mandate of the government, and we have taken also inputs from our industrial partners, including top companies like Cadence, like Micron, like Andaritsu, and others, that what should be done, what skills should be imparted to the budding engineers or even the working engineers who wish to upscale and take a different field, what skills should be imparted. And based on their inputs, we have come to the conclusion that we should be taking this particular I should, or at least at this point of time, I should be talking in terms of why and how it should be done. So the growing demand from the artificial intelligence, you have seen how Chat GPT and other such applications are working. But on the back of it, you must be knowing that GPUs, that is the graphical processing units, are playing the key roles. And again, the GPUs are a part of the semiconductor business. So they are the those specific ASIC application specific ICs, ASIC ICs, which are made again not in India, and we are heavily dependent on it. In fact, only one or two companies, Nvidia and AMD, have a kind of a monopoly on it. So someday we plan to have our own GPU system in India, getting manufactured here in India, so that we are not dependent on any other country for our AI, 5G, and other needs, because this is going to play a critical role in the development of our nation. So growing demand from AI, 5G, and automotive industry. Then now we are figuring out that Moore's law. So this Moore's law is the basic of the semiconductor industry, which says that every 5 years the number of transistors or active device on an IC gets doubled. So for the last just 30 for around 50 years, this law has proven to be correct. But now with time, we are facing some kind of a limitation in terms of power integrity, in terms of packing density, in terms of maintaining the form factor and other such things, that a new way of handling semiconductor products or designing and manufacturing semiconductor products has become the need of the hour. So Moore's law is obviously still applicable, but it is showing some kind of a saturation. So we are figuring out how to bypass this particular limitations and still continue with the growth of the semiconductor high speed systems. Third, we wish to tell you how so the second and the third is the same of the Moore's law and how to bypass it. The third is a kind of a heterogeneous integration and 3D packaging. This particular masterclass or webinar and is the future, and the following skilling programs will be more about this kind of a unique uh, uh, imparting this kind of a unique skilling and the knowledge base to the participants, in which these kind of in 3D packaging and and heterogeneous integration of ICs will be taught. And not only will be taught, but the participants will have a first-hand experience of how those kind of products which have these components function and can be used in the industry. Sumiti, just the next slide. Yeah. So just going through the basic definitions, as I just said that Moore's law has to be, the limitations of Moore's law has to be tackled, and we are figuring out some methodologies of without breaking Moore's law or without inventing any other law, how to still ensure that the progress of semiconductor ICs and semiconductor products uh, uh, is achieved in the similar fashion what we have seen in the last 30 years. So some of the concepts which have come to the fore and the last 10 or 15 years, they have proven very right. They are, some of them are called heterogeneous integration. So when you have a different kind of ICs, like you have a memory IC based on NAND, you have some ICs based on flash, DRAMs, DDRAMs, and you are running a system which also includes some kind of logic devices, and you have to integrate it. So the heterogeneous integration concept comes into play, because heterogeneous here says that different kind of ICs. So one is having memory, the one IC number one may be having a role of a memory device, the IC number two may be a logic device, and both have to speak to each other. So both have to communicate with each other. So what kind of system integration approach we need to take, and that says about the heterogeneous integration of how to put it in a single package. Now again, 3D packaging. So heterogeneous integration, when I say, it can be planar, so ICs can be side by side. But when I come to 3D packaging, 3D packaging is a special subset of heterogeneous integration, in which the ICs are placed one above each other, so stacked or vertical. And we do such kind of placement, routing, and floor planning that the whole system becomes absolutely flawless. So when the IC1 interconnects and talks to IC number 2 or 3, there is no glitch at all. They will function as if they are functioning independently, although they will be sitting just above each other and will be connected through connects, which we'll just see. They will be called through silicon wires, TSVs. So this 3D packaging is just a special case of heterogeneous integration, in which we are bringing a lot of different ICs and combining it together. So the whole idea is to make everything miniaturized. It has different advantages, but also has got a lot of challenges, which we will be looking in some time. I just saw a message from some member asking for kind of a uh, software required for these kind of things. So there are companies, various EDA tool companies, so including Cadence, including Synopsys, including ANSYS. They have got different kind of the proprietary softwares which are used for these kind of integration. For example, as most of you know, Virtuoso or Analog Design and Environment, ADE, are the proprietary software of Cadence. In a similar way, ANSYS has got its own tools which does these kind of floor planning and does these kind of integrations. So the next slide. So yeah, so this is a visual depiction of what I just told our participants, that when we go for heterogeneous integration and 3D packaging and chiplet packaging, these are how we interconnect them. So bumping and interconnection. So bumping is a sort of you can say small nodes or small dots, and an array of small dots made up of either copper or the alloy of copper and silver, CuAg, which increases its conductivity, and on top of those bumps will sit our chiplets and or the pads, and then we do some kind of in soldering, ultrasonic soldering, to join the various ICs. So these are some of the ways in which we do the integration and soldering. So if you can see, there are a lot of different components. This is what we were I was saying when I said that heterogeneous integration. So you can see in one single system, we have antenna, we have sensors, MEMS-based sensors. MEMS are essentially sensors and actuators. These are the special category ICs which have mechanical elements ingrained in it. As you can also see, we have silicon photonic devices are now very common, because instead of electrical signals, they use the specific wavelength photonic signals, which increases the speed and hence increases the bandwidth of our product. So next slide, Energy. Right. So this is a very zoomed in version of what you just saw. You can just see how we have put various different kind of my ICs. So this is a depiction of the heterogeneous integration and in a 3D format. So this is a 3D packaging. So the devices are packed in a 3D, so XYZ format. So the devices are stacked one above each other, and since devices are of different natures with different functionality, so the difference in functionality makes them heterogeneous, and the way they are positioned on each other makes them 3D. So this is a heterogeneous integration in a 3D fashion of my packaging. So here you can see DRAM core is there on the top, memory devices is on top. It can be even at the bottom also, but here I have depicted on the top part. You see the bottom part is the read and write logic circuitries. So the read and write logic circuitries can be differential amplifiers or operational amplifiers. So in a way, they are the analog devices or analog ICs, which are at the bottom. Then you can see the IO buffers. IO buffers are again, if some of our students are from the electrical background, they are simply the op amps connected in a special fashion, so that there is kind of an isolation between the power rail lines bit of the input and output circuitry. So we have IO buffers, we have IO pads, we have DRAMs, we have read and write logic circuits, and so this is an amalgamation of different kind of ICs, so it makes it heterogeneous, and these ICs are put one above each other. So it makes it a 3D representation, and they are connected through a through silicon wire. So these silicon wires are special kind of a very finely drilled wires. Those drilling are done either in a very sophisticated laser way, and then they are filled with either high purity copper or copper and silver amalgamated alloy. So this is how the packagings are done for the highly complex subsystems. Next presentation slide, please. Yeah, so this is the technologies in which I was just explaining. The HI stands for heterogeneous integration, and 3D packaging is the representation. So how we have connected these things. So TSV stands for through silicon wire. Through silicon means the different layer of silicons have been punched through laser beams, those are very fine quality. So the diameter never crosses 20 micron width. So that is the level of accuracy we need to maintain. And then we have micro bumps, that is these semicircular array of semicircular alloys on which we place our ICs and wafers, and we do some kind of a soldering. So that is called micro bumps. And hybrid bonding means the bonding is a mixture of TSV, micro bumps, and the traditional line wiring. So these kind of technologies we generally use for packaging, the modern packaging. Silicon imposers are the intermediate layers. They are made of either of the high quality glass or silica, or even the ceramics, or doped silicon. These imposers are used as an intermediate layer for stacking multiple different ICs in a horizontal pattern. So these are the kind of layers on which different ICs, logic ICs, memory ICs, and other IO ICs, they will be stacked next to each other, not in a 3D fashion, but next to each other. So this falls under HI categories. So again, the wafer level packaging is again a special kind of packaging. In fact, one of the special kind of packaging is also called chip on wafer. This is a TSMC proprietary technology, and which is you can see CoWoS. That is also, so CoWoS is a type of technology which was formulated by TSMC, Taiwan's Semiconductor Manufacturing Corporation. Foveros is by Intel, and similarly in Info is from AMD. So these are the different kind of packaging technologies in which they use different kind of materials, but essentially the architecture is the same. The idea of having different kind of technologies is mainly commercial, but apart from commercial, they also adheres to different kind of user case. So for example, CoWoS is a TSMC. TSMC is essentially into memory and analog IC design. So in that case, their user demand is different. So the kind of materials they use is a little different. Foveros is essentially given by Intel, which is into the manufacturing of CPUs, central processing units. So they have a very specific demand in terms of, say, speed, latency, power management. So they have a very different set of materials which they use for their own integration. So these are the different types of integration which different companies use as per their R&D and also as per their end users. Next slide, please. So here we can see just the last one. Yes. So here we can see how this advanced packaging, in the present day advanced packaging, has evolved from the basic packaging which used to happen in the 70s and 80s. So the earlier, so the first such processor from Motorola, which came in 1970s, 4004, and then Intel also came up with this another version of 4004. Then 8085 came, 8086 came, and then the Pentium chipset started. So these things have started from those era, and now we have reached a point in which the palm tops are more powerful and have much more bandwidth and memory than these older generation bigger computers. And this one of the main reasons that we have achieved this is because of the advanced packaging technology of today. And it is apart from the various advances in the material sciences, various advances in the fabrication technology. Like earlier, it used to be a normal photolithography. Now it is the extreme UV photolithography. So the kind of imprints which we are able to do for the fabrication is of a very high quality. That is why we have come from 350 micron technology node to 3 or 7 nanometer technology node. So this is on the side of the technology. But apart from it, we have also achieved commendable success on packaging technology. Here, the participants should note that in the recent times, Government of India's main focus is to introduce companies in India which are into packaging to start with this ecosystem, which are involved in the advanced packaging technologies. These are the companies like Micron is starting its packaging industry. It is called OSAT. So packaging industry is coming up in India through Micron or through Tata Electronics. These are the gateways of the major ecosystem of the semiconductor industry. When Taiwan was establishing its semiconductor industry in the early 80s, the first thing it started to build was the packaging industry. That so there are two reasons. One is that the job demand is tremendous, because here the manual intervention is required in fabrication and all such things. Most of the masking things, making of masks, making of doing the photolithography, these are mainly automated processes. So human intervention is less, and with the kind of AI which we are intervention and adaptation of AI in modern industry, we are seeing the kind of automation we are seeing in modern industry. Human requirement or the kind of employment generation which generally happens in modern industry will not be the case for the core semiconductor industry, so to say. So there will not be much demand in the factory production or the factory setup of photolithography, but there will be huge requirement of manpower when it will come to advanced packaging, because packaging not only requires human intervention, but it also requires a lot of different testing parameters. So when you go for a very advanced packaging, so before you finalize the packaging, before you do the final packaging, you have to be very sure that your individual components, individual ICs are in their best shape and are giving the best quality outputs. Then only you proceed for any kind of final assembly. So here manpower requirement will be huge. And if you have seen the reports in the recent times, that Micron is asking for for skilled manpower, or in the recent times we have seen Tata Electronics sending its manpower to Taiwan to learn the skills of the trade. Essentially they are going to learn the tricks and the skills of packaging. That is why this packaging thing is so important, and we are trying our utmost focus to give this a proper platform. So when Madhukar ji was showcasing the entire bouquet of instruments, it was very important to understand that those were the testing instruments that are used in some stage of testing the ICs and making the test beds. Once that is done, only then the final packaging is takes place. And this particular thing, every individual and every participant who is eager to make his career in this particular field should understand that you must be having a very sound understanding of not only electronics and ICs, IC manufacturing, but also you should be having a very fine understanding of what kind of testing has to be done, what kind of testing should be done, and how it is done. So a good understanding of the testing, test beds and test equipments are required. Now coming back to the evolution of advanced packaging, as you can see, we have gone from wire bonding. So a normal wire bonding means that the your dice, that is the single wafer based IC, is clubbed with the pads, the outside world pads, through normal copper wires. So that was what was the case in the early 80s, late 80s and the early 90s. Then we have gone for the flip chip bonding. Flip chip bonding, FC bonding, is that you just flip your active part of your IC wafer die, and then you bond it on through a bump. That is, there is no wire bonding. Why it is required? So when we go for a very high speed interconnects or very high speed some kind of a processor, so the kind of an RC delay. So RC delay is the Elmore delay, which everybody must be knowing. So when signal travels on a copper circuit or a copper wire, so there is always an RC element in so resistor and capacitive element embedded in any kind of a interconnect. So that the charging and discharging of those RC elements, which takes the form of some kind of a delay. So that happens. So to remove or to minimize that kind of a delay, we have gone from wire bonding to flip chip bonding. So after flip chip bonding, again we have gone to 2.5D. So 2.5D is a industry name which happened between the flip chip stage and the 3D modern 3D stack stage. So in 2.5D, it is a mix of flip chip and 3D stacking. So now we have come to a 3D stacking, in which multiple layers are stacked one above each other and connected through TSVs, through silicon wires, and those numbers can be huge. In fact, can be more than 15 or 20 in the vertical stacks. Now we have come to the level of a chiplet. Chiplet is, you can think of chiplet as the small bricks which are used to manufacture a wall. So suppose your final product is a wall, but you are not making a wall out of one single element of bricks, but multiple smaller bricks. So chiplets are similar to those bricks. They are the smallest ICs which can be produced, and then they are brought together and joined in particular fashion, either in 3D way or through interposer, and then they are made out to be a system. This is the latest technology. There are various advantages, but there are multiple challenges also. One of the challenges is obviously when you is to manage such kind of handling multiple different elements of chips in terms of latency, in terms of power, in terms of synchronization. So multiple challenges arise, but still these days the complex systems are being manufactured in a chiplet form. So people who may be aware, earlier there used to be a wave of called system on a chips, SoC. So SoC used to be a kind of a system in which one single one system used to be manufactured in a proper integrated fashion. So suppose a computer CPU had to be manufactured. So the entire fabrication used to be done in a one go process. So that fabrication would entail fabrication of memory, of the ALU, of the buses. Everything used to happen at the same time on the same wafer. Now with chiplets, what we do is that we manufacture memory separately. In fact, various stages of memory can also be manufactured separately, like read and write circuitry can be manufactured differently. That will be one chiplet. the storage part will be another chiplet, then we will combine it together and we'll make it a final memory. So this is how the packaging are being done these days. This is also very important from the supply chain point of view, because some countries may be very good in the design of your storage elements. So Taiwan, for example, may be very good in the manufacture of storage elements, storage part. But interconnects, maybe some other countries, suppose Netherlands or Japan, may be very good in designing of your interconnects. So what the basic business sense says is that you bring in the storage elements from Taiwan, you bring in your read writes circuitry from Japan, and then you do the integration. So this is how the chiplets work, and they fall in the category of comparative advantage. And this is very important from semiconductor industry point of view, because semiconductor industry still runs on a very thin margin, because not only because of the competition, but the kind of input or the kind of capital which is required is huge, and the market is still growing. So the semiconductor industry traditionally works on a margin of 8 to 10%. So even 1% or 2% of additional margin or advantage is of huge benefit. So these kind of things, chiplets and all, are not only important from technology point of view, but also from a business point of view, and that everybody should understand these issues very keenly and thoroughly, because in India we are trying to take advantages of these kind of tricks. Now, I have just seen, is chiplet solution effective for small system design? Absolutely, chiplet solution is fantastic for small system design. When you say small system design, I may think of something like a normal processor, or a reader, or something like a handheld device or something. But when you go for a GPU kind of an application, then chiplet is not that important, or now it's not that preferred a choice. But as far as we understand, there are some technologies, especially in South Korea, which are trying to have chiplet technologies even for the manufacture of GPUs. But we are not very sure of what kind of results we have got. But for smaller systems, like for example biometric reading system, so chiplet technologies are essentially used for all kind of biometric reading systems. So the display devices are kind of one part, then the reading part will be another, the storage part will be another, their wireless connectivity can be another. So there will be 3 or 4 kind of chiplets. We will come and integrate it. So this is how the in India, there is a phrase which government is trying to promote. It's called electronic system design and manufacturing. It is called ESDM industry. It is happening for the last 10, 12 years, but in the recent times, we have seen that major impetus from the government is happening. Lot many companies have shown interest. Government is also trying to uh, uh, give every kind of subsidy and incentives in terms of finance, in terms of other export incentives and all, so that final electronic manufacturing happens in India. That manufacturing activity at this point of time and in the near future is solely dependent on the chiplet technologies. We will be till whatever technologies we are very confident of, or we are self-reliant, those kind of technologies we will be manufacturing. But for the rest of the things, we will be still importing, but we will still be doing final integration. One of the final example is the kind of Apple phones which are being manufactured here in India at this point of time. You can think of this as one of the major success stories also of India, and and the successful implementation of government policies. So we still import, we don't manufacture much of the things, but we import lot of things, the components which goes into the Apple computers and Apple iPads. But we do this kind of thing here in India, the integration, and that is a representation of the chiplet technologies.
Varunji, I think Varunji, we're running out of time. It's already 9:30.
So we can just go through. I think only 2 or 3 slides is required. Apart from it, I think I have given them quite a good understanding
So
of
we
how
can take up some questions, sir.
that is
Some
even
very
better.
good questions are there. So we can take up some questions, and I can share a little bit information about the program that we are looking at
Yes,
launching.
yes, yes.
And around those programs, we could probably take up the questions. So let me just start the program details so that everybody is. So, sir,
Yes, yes, yes.
I would like to share one thing with all the participants that IIT Delhi and Drive, Department of Electrical Engineering is launching an executive program in ESDM and semiconductor technology.
Correct. Yes, yes,
So
yes.
it's going to be a 6 months, 100 hours live program. So the interesting part about this entire program is that I'll straight away, it's a program designed for all aspects of all backgrounds of engineers, electronics engineers, industry professionals, ECE graduates. I see a lot of fresher graduates, PCB embedded systems technician, research scholars who want to build up knowledge about the latest and advanced semiconductor and ESDM technologies. So what are we looking at in this particular program? Is straight away go to the program structure, because this is going to be explaining the entire structure. So Drive has closely collaborated with industries, semiconductor industry, to find out how this semiconductor industry will be growing in the next 4 to 5 years. And based upon the requirements of the industry, India Semiconductor Mission, and also looking at the global trends, Drive and IIT Delhi have created a course program, a structure, which is an advanced training program designed specifically for engineers who are looking at capturing the next wave of career growth in semiconductor industry. So as you can say that the basics, so industry is full of course programs which is teaching you basics of semiconductor technologies. This is one program in the country as of now, and we can proudly say that we have tried to build up an advanced program in tune with Semiconductor Mission of India and global trends. So, and the most important thing which I would like to highlight with you is that this is in this 100 hours of program, you will see that 24 hours of practical sessions are there. And in addition to this 24 hours, there is going to be a 2 days boot camp at IIT Delhi in the labs of IIT Delhi, supported by Anritsu's products, on which you will be getting hands-on learning. So if you look at the courses around, you'll find that majority of the courses are conducting their entire delivery online, and missing on the practical aspect. This is one course which is actually having almost around 40% of the total hours dedicated to hands-on learning. So this is becomes the first USP of the program. And if you will go through the program structure, we have various modules, and I will request Varunji to explain the perspective while picking up these modules. So I'll start with the basics. Varunji, if you could explain these program outlines to the people, and if you
Right.
have
So
questions,
you
we'll
can,
take
if
them
you
up.
can just go a little, yeah. So for the prospective students, we can just say that this is we are going to start one of the finest programs in which will be launched in India, and there are two aspects of it. One is that this program has been conceptualized under the guidance of India's topmost semiconductor engineers and faculty members who have been part of IIT Delhi and also of University of California, San Diego, UCSD. And also we have along with us our industry partners, including Aniritsu, with whom and Aniritsu has been closely working with IIT Delhi for a very long time. In fact, from time to time, they have shown and given their test beds. They have deployed their test beds in IIT Delhi, on which the the engineering graduates who wish to upskill have gone for the training. And apart from it, this program also includes inputs from the incoming semiconductor industry, which are trying to set up their shops in India, including Micron and others. So we this whole syllabus has been vetted not only by the traditional academics in India and abroad, but also from the industry people who are looking for such kind of skilled manpower. In fact, as I just mentioned a few minutes back, Tata Electronics had to send their engineers and other peoples to Taiwan to have first-hand experience and upgradation. But such kind of things are not a sustainable thing. We need to have our skilled manpower pool in India. So this program is one such attempt, a serious attempt, in which we feel that once gone through this particular course, people will be more than ready, and even industry will be more than happy to have them on board. So if you can see, if these students can see, these are the kind of subtopics and topics which we have mentioned. These are how closely they are related with the actual manufacturing. So people need to understand that here we are not only giving them the idea for design aspects, but we intend to have more understanding and imparting the skills for manufacturing abilities, and how to think like a manufacturer. And by manufacturing, we not only mean the semiconductor only, but also the entire electronic industry. So electronic system design and manufacturing. People should understand electronic system design and manufacturing is the mother lobe of everything which is happening in India. So whether it is the semiconductor mission, that also is a sub part of electronic system design and manufacturing, whether it is the EV electronic vehicles, that is also a part of the ESDM, electronic system design manufacturing, whether it is related to solar industry, solar manufacturing, and all such things, that again is related to the electronic system design and manufacturing. If you can just go, Sumit on the next slide, I can just see. Yeah, so here we have just seen the semiconductor manufacturing. Just a little ahead, I want to show a subtopic in which just one more ahead. Yeah, so if students can just see here, we have specifically mentioned critical system level issues. This, when I say system means electronic system, and it includes systems from semiconductor, it includes systems from EV industry, it includes system from automotive industry, it includes systems from telecom, it includes systems from prospective 5G and 6G. So these critical system level issues are the skills which any industry will like their prospective employees to know. And this is what is lacking in all kind of courses which are being run either traditionally or in the imparting courses, the capacity building courses. These are essentially the topics and subtopics which we are trying to focus. And when Madhukar ji was giving his presentation, the instruments which you people have for the first time you have seen, these are the things which you people should be knowing more in more details, rather than just having a cursory glance on the other shallow topics. So this is where what will make you stand apart from your rest of the peers. Yeah. Sumit, just if you can go back a little, just back. Yeah, so the next one of fifth and sixth. Yeah, so here also you see, as I was delving on the topic advanced packaging topics, so in which we have included thermal management in packaging. So thermal management is one such topic which is generally not heard of in electronics and semiconductor and such industries. It is generally reserved for mechanical and such kind of application chemicals. It is for the first time that such kind of things will be taught here, and from that perspective of a designer, of the perspective of a manufacturer, not only a designer. So when you are going to manufacture a particular product, you should be having a first hand feel or first hand understanding of why thermal management is also important from a system perspective. So these are the some of the skills which the industry is looking for is employees, and this is what the government, we from the government is trying our level best to impart to the interested people.
Varunji, we have an interesting question from Manhar right now, which I would like to take up.
Mhm.
For ESD, will there be specific real-time testing and debug issues dealt with? Class test coverage, pre and
Yes,
post
yes, yes.
test and
So
imaging?
if yes, so debugging and all such things will be a core of when we will be going for the critical system level issues. So
Yeah.
debugging essentially becomes a part of it. When you go for a critical system level issues, debugging always comes there.
And how to differentiate ESD from EOS issues?
So these kind of topics, so ESD and EOS. So essentially, what you have to understand is that when all the electronic systems are having this, are prone to ESD, and one of the basic ways of dealing with such kind of thing is the protective mechanism. So you have to understand from the system perspective of how the diodes have to be used. So when any electronic system is functioning and it stores the charge, so that essentially creates a kind of a capacity mechanism there. And then you have to deal with those kind of a stored spurious charges. So how you deal with the discharging of the such spurious signals or such spurious stored charges, and then you make your whole system very fresh to start to work again. So these are the essential components of ESDs and EOS. So these will be dealt in detail when we go for the critical system level issues. So essentially, it is this spurious stored charges, because every electronic system is having is has a capacitive effect in nature. So whenever a component or whenever subsystem works, it stores charges which doesn't get discharged completely whenever you switch off the things. So it is always some kind of a capacitive mechanism. So or there is a spurious charge, and because of that charge there is a spurious electrical field which is present there, which we have to deal with it.
Okay, sir, I want Swati, would you like to ask your question, which you had? I'm just unmuting you. Please ask your question directly to Varun. Swati Bauge, would you like to ask your question? Okay, sir. Let me find out her question. I'll ask her. So there are a lot of people from mechanical design engineers. So would this be
It will
the
be
right
good to
course?
have our mechanical engineers on board, because packaging is all about mechanical engineering. So stress tests of packaging, thermal analysis of packaging. These are essentially the domain of mechanical engineers, which we have, and those concepts we have taken into the packaging industry. So mechanical engineers are very much suited. In fact, the modern semiconductor industry has become very interdisciplinary. So as I was saying, it is not only the mechanical engineers who are more than welcome, but also people from backgrounds like chemical engineering, from metallurgy. They're all very welcome, because semiconductors and ESDM are not is not only about circuits. It is also about it's also about the material sciences. So we are not only dealing with only silicon, but we are also dealing with products, materials like gallium nitride, indium phosphide, and such things. So people from metallurgy, people from chemical engineering, people from mechanical engineering, they are all very welcome. The way this course will be taken forward will be such that it will become very interdisciplinary in approach, and the people who will go through it will be industry ready from day one. And please remember that electronic system design and manufacturing, as well as the semiconductor industry, is a very interdisciplinary field. It is not the core domain of only electronics and electrical engineers.
So there is a suggestion from Senthil. He's saying that can you focus on package design in Cadence APD or Mentor instead of PCB design, which is not an advanced level course in Altium design.
So
Then
that the suggestion is well taken, but for 100-hour course, it becomes a little difficult to include those very sophisticated things. Had it been 150 or 200-hour course, we could have seen it, but we will try to incorporate his suggestions as much as possible. But these LTM based PCB design, he should not be thinking as a very basic course, because when 24 layer PCB will be designed, it will be an extremely complex job.
okay. Taking forward, sir, I would like you to share some details about the boot camp and lab training that we are
Yeah,
planning.
so the kind of hands-on experience which we wish to give to our prospective students will be twofold. One obviously will be the a very uh, big emphasis on the complex PCB design on the LTMs. Obviously, that will be one of our things, and it will be taken care of people from industry itself who are adept of designing these things on a daily basis. So people who will be dealing, who will be telling these things, who will be doing these kind of uh, uh, live projects are the people who design these kind of products. So multiple multi-layer, 8 layer, 10 layer, 12 layer, 24 layer PCBs on LTM. So this is how we plan to engross and involve our students in the live projects which will be used in some kind of a particular product, and they will be able to see. So this is one, and that will be very comprehensive. It will not only be the design of PCB, but also will be the analysis of PCB, of thermal analysis, stress analysis. Such kind of analysis also will be a part of the PCB design. And this particular input we have got from our industry partners, the end users like Micron and others, that please make sure that the skilled people understand the importance of PCB design, because ultimately ICs have to be placed on the PCBs before they make a whole system. So understanding the intricacies of PCB is also as important as understanding the semiconductors. So this is one. And when I see PCB design, it starts from the very basic. So what kind of materials should we use for PCB? Whether it should be a doroid material, whether it should be some laminate material, why it should be used, why, what kind of end use thing has to have dictates what kind of materials we are going to take, what kind of permittivity and conductivity has to be taken into account. Every such thing has to be taught, and then only the design process of a PCB starts. So PCBs, the designing of PCB doesn't just mean that opening a software and just pulling out the things. It starts from the understanding of the materials of PCB. It starts from, and it deals in depth with why this particular PCB will only work and not any other kind of a PCB. Why 3 layer, why 5 layer, how, what kind of a routing, what kind of a grounding, why grounding, if grounding fails, what kind of a problem can happen, what is the kind of a fringe field we have to look into effect, how a complex system which are having multiple ICs sitting beside each other can be affected if a PCB's trace means the interconnects are not of a particular width, or when the groundings fail, what will happen to the particular part of an IC. Every such thing has to be dealt with, and this is one of the very complex areas in which, in fact, modern EDA tool makers, including Cadence and Synopsys, always keep looking for high quality PCB designers. Unfortunately, we are not able to produce even that. So India still imports very high quality PCBs from countries like Taiwan and Germany. So this is one of the reasons why we have particularly included the PCB design aspect, and that also on the LTM.
So, Varunji, I would like to ask about the faculties who would
Yeah,
be.
though so we will be faculties from obviously from the IITs and the people from our, I personally I'll be taking a lot of the topics there, and industry also people will be there, including Akash, who is a junior from IIT Mumbai and IIT Delhi, both from here, and also we will be including people from industry who will be taking first hand this classes from this on these particular topics.
Okay, right, sir. So, coming back to this entire course schedule, we're looking at starting the session from in July. Towards the end of July, we wish to start the session, and it's going to be a 6 months blended program. Classes will be.
Yeah, eligibility we can ask for BE, BTech, EC, EE, but the people from mechanical and biomedical also are more than welcome. Instrumentation are more than welcome. Mechanical, obviously, mechanical and chemicals industry are also more than welcome, because we have those kind of things, subtopics which will be of great interest to them.
Okay, there is Kirtan, sir. He's presently in
First year,
first
second
or
semester
second sem.
EC. Can I apply for this program? Obviously, he can apply, provided he has gone through the basic electronics courses. He understands the basics of diodes, he understands the basics of materials. Then he will be more than happy. We will be more than happy to have him on board. He will be much ahead of his peers once he is done with this course.
Now, coming to the course fees of this course program, so Drive and ZRA both researched a lot about the various price points at which semiconductor courses are being offered in the country. We checked out ISE programs, we checked out a couple of IIT programs. We also went outside India to check out what is the content and what is the kind of prices. And we found that the 6 months or 4 months programs are being priced upwards of 2 lakhs. So we checked out a couple of programs from ISCs and IITs which have been priced upwards of 1.75, 2.75, 3.5 lakh rupees, which are actually covering quite basic topics. And then we thought of starting working out a program which is industry relevant, aligned to Semiconductor Mission of India, and Drive has always been looking at offering value for money courses which people can afford. So a 6 months, 100 hours with uh, uh, almost 2 days of boot camp at IIT Delhi has been priced at 1 lakh rupees plus GST. There is going to be an application fees of 2,000 rupees. You can definitely pay this course fee in 4 installments over a period of 4 months, and various options are available. We also have collaborations to get you education loans to fund this course program if you wish. So our counselors are there to support you uh, 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 in exploring various opportunities so that you don't compromise and can enroll into the course program. We'll be more than happy to assist you, and you could contact. We'll be sending the recordings as well as the program brochure with all of you on email. Uh, and many of you are already in touch with our counselors, so our counselors would reach out to you to explore your interest in this particular program. And now we can take up some questions. We are already running way ahead of our stipulated time. So if you would like to have any specific questions, or if you'd like to connect with Varun ji or our eminent experts, please feel free to contact us on the email ID mentioned here. We'll be happy to guide you in person as well. So thank you, Varun ji, for today's session, and Vinod Kakde ji for taking out time. I'm not sure whether he's there or not. He's left. Okay, so thank you everyone for this wonderful evening, and uh, looking forward to connect again. Please do follow Learn ESDM. You need to and let me just share. Please go to LinkedIn and just share the just find out this particular page. You will be able to find the page here, and you could all connect with this page. We have created a page which you can follow. I think in the morning we've got so please follow this particular page, and we'll be happy. I'm putting in the link again in the chat box. Please follow this. All the recordings, course brochures, course related updates would be coming here. And thank you everyone. Thank you, Varunji. Varunji is here. Yeah. Thank you, Varunji.
Uh, Hello, yeah.
Yes.
Thank you, Sumit. It was nice
Thank you,
to have
Madhukar
such a
Tripathi ji from Anuritsu. Is he here?
participants.
Is he there? Let me just thank you, sir. Thank you so much for taking out time, sir, and we look forward to
Yes,
collaborating with you for
Madhukar
this
ji is
course.
our ecosystem partner. We are working very closely with him, and he is a very senior and experienced technical hand. And Retsu, as everybody knows, is one of the finest global companies when it comes
Yes.
to the modern
Yes.
equipments. So thank you, sir, for taking time out and telling our people. what kind of
Thank you,
different
Madhukar ji.
equipments
Thank
are
you so
there.
much.
Yeah, thank you.
Yeah, all right. Appreciate your efforts also. Good night. Thank you so
Thank
much.
you.
Good night. Good night. Thank you.